Today we're going to talk about how to create linear equations from context. Let's start with a cell phone company that charges a monthly $20 fee plus 5 cents for every minute used for calls. What would that look like for a customer? And how would a customer find out how much they would pay for any given number of minutes? Well, it turns out that this is the type of problem you've been preparing for. Learning all of the context, learning to write expressions from context, that's going to help us out here. In life, you can use your skills of writing equations and graphing, that'll help you too, to find solutions to a multitude of different types of questions. Today we're going to write an equation to represent the total the phone company charges based on the number of minutes a customer uses, and using that equation we can come up with an answer for anyone. So let's take a look. We want to take these sentences very, very literally. We know that this cell phone company is first of all going to charge a $20 fee. And after that $20 fee, they're going to pay 5 cents per minute. Remember, the word per from our past lesson means multiplication. We're going to use that to our advantage today. So we have our $20 flat fee. That won't change from month to month to month. You are always going to be charged that $20 fee. Plus, the word plus, 5 cents per minute. Again, per means multiplication, and our unknown is the number of minutes, so that's where our variable is going to come into play. So we have 20 plus 0.05x, where x is the number of minutes used. Be cautious about the 5 cents. One of the most common mistakes that students make is to write a 5 instead of 0.05 when it comes to values like 5 cents. If I wanted to write this in slope-intercept form, then I could switch the two terms. I could have 0.05x plus 20 and set it equal to y, where y is the total amount charged, and again, x is the number of minutes. Let's try that again with a taxi company. A taxi company in Kansas City charges $3 for a ride plus $2 for every mile driven. Write an equation that models this scenario. Looking at the sentence, let's translate what's happening for a person taking a taxi. First of all, they're charged $3, and that's not going to change for any customer. Plus $2 for every mile. Could we rewrite that as $2 per mile? You bet we could. Every and per are both going to be multiplication. The unknown in this case is x, and that's going to stand for the number of miles ridden. So we have 3 plus 2x, where x is the number of miles driven. In slope-intercept form, that's going to look like y equals 2x plus 3, again where x is the number of miles and y is the total amount charged. Let's try this one more time with a plane. A Boeing 747 starts out a long flight with about 57,260 gallons of fuel in its tank. the airplane uses an average of 5 gallons of fuel per mile. Write an equation that models the amount of fuel in the tank. This plane starts out with 57,260 gallons of fuel. Now here's my question. In the previous two situations, we added money for each minute or for each mile. Does this airplane take on fuel and add fuel to its tank while it's flying, or does it lose fuel when it's flying? Well, since it uses fuel, this time instead of adding fuel to its tank, we're going to have to subtract fuel. Be very conscientious of whether you're adding or subtracting in these situations. We're subtracting 5 gallons per mile. Per means multiplication, and the unknown here is the number of miles. So we have 57,260 minus 5x, where x is the number of miles. If we want to write this in slope-intercept form, we would write it as y equals negative 5x plus 57,260, where x is the number of miles flown and y is the number of gallons left. All right, we're making today short and sweet. Have a great day, and I'll see you next time.